Okay, students, good morning to all of you, Nana. So, we are discussing objective problems now. Yes. So, it is opening. Yes, here is your objective problem, Nana. Now, which question we are solving? I think so, 75 question. Question number 75 we are solving. No? Yes. Question number 75, Nana. See question number 75. What they have given? 10 members are there. Only 10 members. I already told you to join to the classes daily. Question number 75. An interference experiment. Third bright fringe is obtained at a point on a screen with a light of 700 nanometers. Okay. So which bright fringe? Third bright fringe. Means n is equal to 3. Okay. What is the wavelength of light used? 700 nanometers. Okay. Next, what they are saying, what should be the wavelength of light in order to obtain fifth bright fringe? So to get n is equal to 5, what is the wavelength they are asking? Okay. Simple, Nana. At the same distance. See, condition is at the same distance. So you know, distance of nth bright fringe is n lambda capital D by small d. However, they are not saying anything about capital D and small d. Okay, so we can cancel them. Simply y is equal to n lambda. When condition is small d and capital D, they are not saying anything. Okay, now because distance y should be constant, if this distance y should be constant, same means this n into lambda should be constant. N into lambda should be constant. Then only it will be same. Did you got my point? What I am saying? Clear? Yes. So that means we can write simply, we can write n1 lambda 1 is equal to n2 lambda 2. We can write. Okay, what we can write, Nana? n1 lambda 1 should be equal to n2 lambda 2. Okay, n1 is given 3, n2 lambda 1 is given 700 nanometers is equal to n2 is given as 5. Lambda 2 is unknown, we need to find. So lambda 2 is equal to 3 7 how much? 21 00 nanometers upon 5. Correct? Yes. So divide 2100 with 5. 5 ones are 5. How much you will get? 5 fours are 20. 100 will be there still. 5 twos are 10. 0 nanometers. Yes. 420 nanometers. 420 it is. Okay, 420 nanometers. Option 4 is right answer. Point understood? No, because distance y to be same. Y is equal to n lambda capital D by small d. However, they are not saying anything about capital D and small d, and they are saying that y is same. Y is same. That implies n into lambda should be same. That is the reason why I have taken n1 lambda 1 equal to n2 lambda 2. See, in physics, this is only the beauty that depending upon the question, your formula will change. You need to understand the question. That is the main important thing here. So 75 is over. Next 76. They are given that in double slit experiment, if light of wavelength 5000 angstrom is used, then fringe width is 1 millimeter obtained. If now light of wavelength 6000 angstrom is used, without altering the system, without altering the system, new fringe is what? Okay, so lambda 1 I am taking, that is 5000 angstrom given. What is the fringe width? First fringe width is 1 mm. Okay, now lambda 2 wavelength is changed to 6000 angstrom. 6000 angstrom. Then what is the new fringe width they are asking? Yes, we know fringe width formula, beta is equal to lambda capital D by small d. Here they are saying that without altering the system. Without altering the system means capital D and small d remain same. That means beta is directly proportional to lambda. Point understood? No, beta is directly proportional to lambda. We can take, yeah. So by taking that result, we can write beta 2 upon beta 1 is equal to lambda 2 upon lambda 1. Correct? Yes. We need beta 2. So beta 2 is equal to lambda 2 by lambda 1 into beta 1. Finish. Your formula is what? Yes. So what is lambda 2, sir? Lambda 2 is 6000 angstrom. Okay. What is lambda 1, sir? 5000 angstrom. Into what is beta 1, sir? Beta 1 is 1 millimeter. Okay. 1 millimeter return. Okay. So angstrom cancel, 0 zeros cancel. So beta 2 should be equal to 6 by 5 millimeters. 6 by 5 means how much? 1. 5 ones are 5. Point 10 is there. 5 twos are 10 millimeters. Yes, see, 1.2 millimeters should be their answer. Yes, where it is. Yes, here option 3 is right answer. Got it, students? Understood? No? Clear? Yes. Next. Question number, I am going to question number 77. So what they are given? A monochromatic green light it is, remember green light, has a wavelength of 5 into 10 to the power of -7 meters. Okay. The separation between the slits is 1 millimeter. Separation between the slits means small d. How much? 1 millimeter. And wavelength also given. Let us write down 5 into 10 to the power of -7 meters. Okay. The fringe width of interference pattern obtained on a screen at a distance of 2 meter. So capital D at a distance of 2 meter means capital D is equal to 2 meter. What is the fringe width they are asking? Fringe width is lambda capital D by small d. Nana. Substitute this, you will get the answer. It is the just substitution question. Substitute this, you will get the answer. And the answer will be there at the back of your material. You find out. Okay, you do this. Very simple. Need students, you may get this type of questions. Need students, not for JEE. Okay. Now next question number 77 over. Next question number 78. Nana. Question number 78. What they have given? See question number 78. In Young's double slit experiment, they are given in Young's double slit experiment. When wavelength of 700 nanometer is used, fringe width is 0.7 millimeter is obtained. If the wavelength is 500 nanometer used, then what is the fringe width? Simple again formula. Lambda 1, lambda 2 values given and beta 1 value given. Okay. Beta 2 value we need to find. Similar problem. Beta is proportional to lambda formula. Means beta 2 by beta 1 is equal to lambda 2 by lambda 1. Use this formula, you will get the answer. Already this type of question we have solved. Okay, do this also homework. Next question number 79. What will be the effect of fringe width when distance between the slit becomes double? Yes, need students, you may get this type of questions, simple questions. Okay, distance between the slits is double, means small d is equal to double. Okay, fringe width formula what na? Beta is equal to lambda capital D by 2 times of small d. Correct? If see here denominator d increasing means fringe width should decrease. Okay, how much it will decrease? Half time. Yeah, see. So beta dash will become lambda is not changing, capital D is not changing. 2 times of d dash it is happening. Yes. So lambda capital D by 2 times of 2d. It can be written as lambda capital D by 2d into 1 by 2 we can write. This is what? Lambda capital D by 2 small d is what? Beta, original beta. So it will become beta by 2. Means half times. Easy question. You have to understand this. Okay. 80th. Question number 80. Yeah, we are going to diffraction. See, this diffraction is important. Nana. What they have given? See questions, these are analytical questions. The conversation is going on in some room, can be heard by a person outside the room. The reason for this is, see, I am inside this room. Whatever I will talk, this The person who is outside of this room, he can hear. The reason for that is these sound waves, whatever they are coming, they can go, they can bend through these windows, small holes, they can go, they will pass out and they will hear. Means bending of light rays. Bending of light rays is nothing but diffraction of sound. But whereas light we can't see. Yes or no? We can't see the person who is outside, but we can hear whatever he is talking. The reason for that is light cannot bend. Condition is applied here. When wavelength of light is almost equal to wavelength of obstacle, size of the obstacle, then only it will bend, otherwise it can't bend. Whereas wavelength of sound is very large, so it will bend through windows, these all things, so we can hear. Okay, important question, Anna. Conceptual question, important, you have to remember. Next, phenomena of diffraction occurs in what type of waves? Phenomena of diffraction occurs in all types of waves, but condition should be applied. What is the condition? Wavelength of that light wave, whatever the wave, it may be light wave, it may be sound wave, that wavelength should be nearer to the size of the obstacle on which that wave is incident. That is a condition. So it will be applicable for all the kinds of waves, remember. Okay, only in case of light and sound, no. All kinds of waves, yes. For electromagnetic waves and not for matter waves, no. All the types of waves it will be applicable. 81 is option 2 is right answer, Nana. Okay, next 82, question number 82. We are going to question number 82. Yes, where it is? Question number 82. Yeah, here it is. For which of the following ray gives more distinct diffraction? Yes, students, they may ask this type of question for JEE and NEET both. Very simple question, but a lot of concept is there in this. Which of the following ray gives more distinct diffraction? More distinct diffraction in the sense in real life. Okay. See here, X-rays, light rays, gamma rays. All these three comes under light rays only. Electromagnetic rays, electromagnetic waves, means light rays they are. Whereas radio waves also light rays only, electromagnetic waves only. Sir, no. X-rays, gamma rays and radio waves. All are electromagnetic waves only. Light ray is also electromagnetic wave only. Clear? Yes. Now among these all four, which gives more distinct diffraction? Radio waves gives more distinct diffraction, because in real life, whatever these buildings, stones, cars, vehicle obstacles we are having, that size will be almost nearly equal to wavelength of radio waves. Point is important. Remember this question. Okay. Yes. Next, question number 83. All the fringes of diffraction are of unequal width. Diffraction fringes, all the fringes will be unequal width, whereas interference equal width. Remember. Okay. Difference between interference and diffraction you have to study. Okay. 83 is over. Next, 84. Question number 84, Nana. What happens when? Yeah, this is important question. Students, important. What happened when width of the slit aperture is increased in an experiment of single slit diffraction experiment? See here. This is the slit, and here source will be there, and here your screen will be there. Clear? Yes. So light rays are coming, wavefront is coming like this, single slit diffraction it is. Okay. Now from here, so light will spread out like this, and due to this sharp aperture, it will bend also. So the spreading of light will be somewhat more here. This much light will spread. Okay. Now what they are saying that when the width of the slit, if this slit width, this width is increased somewhat if you increase this width, it's like this. If you increase this width, if you increase the width of the slit, this much if you have increased, like this much if you have increased, then what happened to this spreading of light? See, spreading of light will decrease, nana. It will show only this much only, it won't show this now, because light will bend only around the sharp edges. When wavelength of this wavelength should be equal to size of this sharp edges, when this slit size is increased, this aperture size also increase. That means what happened, what happened to that, nana? The size is not equal to wavelength, size has increased, so diffraction will not occur. Due to that, this spreading will be cancelled, only in this region will get light, means this spreading of light will decrease. Very important point, you have to remember that spreading of diffraction region increases. Wrong, students will think like this only, if you slit width increases, this much spreading of light will get. No, it is wrong, spreading of light doesn't increase, spreading of diffraction region decrease. Yes, option 2 is right answer. Reason, I hope you understand. Diffraction occurs only when size wavelength of light is almost near equal to size of this slit or aperture, you can say size of slit. Then only diffraction occurs. If size becomes more, then diffraction, light cannot show diffraction. So straight it will go straight. This spreading will not be there. More this here and here spreading will not be there. Clear? Option 2 is perfect answer for this. You need to remember this. Okay. See option 3 also. See option 3 given. The spread of diffraction region decreases. Yes, correct. And midband becomes narrow. Midband becomes narrow. Yes, this middle band, central band, whatever we will get here. This central band, whatever we will get here, this will become narrow, nana. Yes, perfect. This is also correct. This central band, whatever we will get here on the screen, this will become narrow. Yes, third option is correct. None of the above is wrong. So compared to second option, third option is more perfect. So that's why tick for third option. Here they are given that middle band becomes narrow. Yes, spreading of light decreases, means middle band becomes narrow only. Yes, it is correct. Remember, very important, because this middle band fringe width formula what, central brightness fringe width is 2 lambda capital D by small a. Small a is the width of the slit. Width of the slit. If this a increases, fringe width decreases. That's why this becomes narrow. Reason I am giving you. Clear? Yeah. So third option is perfect answer, not second option. Second option is correct, but compared to third option, second option is wrong, because they did not say about this middle fringe. So that's why third option is perfect. I hope you understand this. Very important point. You need to remember this. Next question number 85. Question number 85. Light waves do not travel strictly in straight line. Can be seen distinctly by which nature? Which nature we can see? Diffraction. Only diffraction. Okay. Clear? Next. In diffraction pattern of single slit aperture, the width of central fringe compared to width of other fringes is double. Central fringe will be double always in diffraction, whereas in interference, central and all remaining fringes will be equal width. Whereas in diffraction, central fringe will be double the width of other fringes, and intensity wise also double. Clear? Remember, this is also important. Next, 87th. 87th options you need to see. Yes, 87th question. Question number 87, Nana. What they have given? They have given that diffraction fringes obtained from the slit aperture are of non-uniform width and non-uniform intensity. Yes, just now I told you. Okay, same width wrong, different width. Okay, correct. But what about intensity? Uniform intensity wrong. So non-uniform width and Non-uniform intensity, yes. Option 4 is right answer. Next, 88. The central fringe obtained in diffraction pattern due to single slit is of minimum intensity, wrong. Of maximum intensity, yes. Okay, clear? And intensity does not depend upon the slit width. Yes, it is wrong. So it is of maximum intensity. Width depends upon the slit width, whereas intensity does not depend upon the slit width. Okay, option 2 is right answer. Next, question number 89. In single slit diffraction experiment pattern, if the light source is used of less wavelength provided the previous one, then width of the central fringe will be, see, question is, in single slit diffraction pattern, if the light source is used of less wavelength than previous one, then width of the central fringe is, see, width of the central fringe formula is 2 times of lambda capital D by small a. Small a is the width of the slit. Capital D is the distance between the slits. Wavelength of light used. Now, if wavelength of lambda is decreased, then width of the central fringe also decreases. Less only. Clear? Option 1 is right answer. Got it, Nana? Next. Question number 89 is over. Question number 19, Nana. What they are given? See again. They are given that in laboratory, diffraction of light by a single slit is being observed. It is observed. If a slit is made slightly narrow, then diffraction pattern. See, just now we have discussed that if this slit is there like this slit is there like this. If this slit width increases, means diffraction spreading decreases. Whereas slit width, if you decrease this slit width, then spreading will increase because diffraction more accurately it will occur. Clear? Yeah. So diffraction pattern will be more spread than before, less spread than before, spread as before, it disappear. These three are wrong. It will be more spread as before, because slit width is decreasing. If you decrease the slit width, diffraction will increase. If you increase the slit width, diffraction will decrease. This is the important point again. Conceptual questions, Nana. Okay. Next, question number 91. For Fraunhofer single slit diffraction, what happened? See. Width of central maxima is proportional to lambda. Yes. Width of central maxima proportional to lambda. Yes, it is directly proportional to lambda. Correct. First option is correct. Next, on increasing the slit width, this is A, you can say. On increasing the slit width, what happened? Central maxima decreases. Yes, perfect. Second option also correct. Next, on making the slit width is equal to A, if you take slit width is equal to lambda, slit width A is equal to lambda, then lambda cancel, you will get 2 times of capital D fringe width. The central fringe spread is 90 degrees plus or minus. Yes, see, here screen will be there. Exactly, it will become double. This much, exactly 90 degrees it will become Nana. Yes, option 3 is also right. So all of the above are correct. Yes, this is your perfect answer. Perfect answer is fourth. Fourth option is all the above are correct. Question number 91. All the above answers are correct. Okay. Option 4 is right answer. Next. Question number 92. In Fraunhofer diffraction by single slit, if the slit width is A and wavelength is lambda, focal length is F, then linear width of central maxima. Central maxima width formula is beta is equal to 2 lambda capital D by A. Clear? Yeah. Now see here, Fraunhofer diffraction, what we will do, Nana? Yes. In front of the slits, this is the slit you imagine. In front of the slit, here source will be there to produce plane wavefront. In Fraunhofer diffraction, we need to get plane wavefront. To produce plane wavefront, we will keep one lens here. Do you remember that point? That we call it as lens L1, and here a screen will be there. Now in front of the screen also we will keep one lens L2, and this focal length is, let us imagine, F. Now as much as possible this lens will keep very near to this slits, means the pattern will be like this. The pattern will be like this. Here we'll keep lens, means this is the focus. Now your image will get exactly at the screen of focal length. That means capital D will be of focal length f. Remember this point, important point, important point I am discussing. Okay, now they are saying that it is 2 is 2 only, lambda is lambda only, whereas D is equal to f, because they are keeping one lens in front of this. Upon a value, what they are saying, then a only. Then what is the bandwidth of central fringe? It is 2 lambda f by a. Where it is? 2 f lambda by a. Yes, option 3 is right answer. What is, students? Very important. This is also important for your JEE students. It is important for NEET students also. It is important. Clear? Important point, Nana. You have to remember. Next, 93. Question number 93. What they have given? See, question number 93 is, in Fraunhofer diffraction obtained by a single slit aperture, the value of path difference for nth order minima. Nth order minima path difference is n lambda, Nana. Minima is n lambda. This is for minima. Minima. And for maxima, path difference should be 2n minus 1 into lambda by 2. You need to remember this direct formulas. So option 1 is right answer. Next, question number 94. Question number 94. A light of source 5000 angstrom wavelength produces single slit diffraction. Okay. The first minima in diffraction pattern is seen. First minima in diffraction pattern is seen. First minima it is. Okay. First minima is seen. Okay. What they are saying? Is seen at a distance of 5 millimeters. So distance is equal to 5 millimeters. Okay. From center maxima. The distance between screen and the slit is capital D is equal to 2 meters they are given. Now width of the slit in millimeters. What is the width of the slit? Width of the slit is what they are asking. What is the width of the slit? Yeah. So formula for nth minima formula is y is equal to nth minima, no, yes, n lambda capital D by small a, slit width. And they are asking for first minima, means n is equal to 1. So it will be y is equal to lambda capital D by a. They are asking a is equal to lambda capital D by y. No, replace these two. Okay. Yeah, lambda value is given. How much, Nana? Lambda value is given is 5000 angstrom. Okay. Lambda is equal to 5000 angstrom. Okay. 5000 angstrom is 5 into 10 to the power of minus 7 meters. Correct? Yes. It is 10 to the power of minus 10. Because of these 3 zeros, it will become 10 to the power of minus 7. So I am writing 5 into 10 to the power of minus 7 into capital D given 2 meters. Yes, I am writing 2 upon y is equal to 5 millimeters. So I am writing 5 into millimeter 10 to the power of minus 3. 5 cancel. 10 to the power of minus 3 cancel with 10 to the power of minus 7. So you will get minus 4. 2 into 10 to the power of minus 4. It is okay. 2 into 10 to the power of minus 4. Can we write this like this? 0.2 into 10 to the power of minus 3. Yes, 10 to the power of minus 3 is called as what? Milli. So 0.2 millimeter is your answer. Yes. So answer is in millimeters. Yes, 0.2 option is correct. 94 option 3 is right answer. Got it, students? Understood now? Next, 95. A plane wavefront of wavelength lambda is equal to 6000 angstrom. Okay, is incident upon a slit of 0.2 millimeter width. Okay, slit width is 0.2 millimeter. Okay, which enables a Fraunhofer diffraction pattern to be obtained on a screen. Capital D is equal to 2 meter. The width of central maxima formula 2 lambda capital D by small a. Just substitution question, substitute, you will get the answer. Okay, it is a substitution question. Do this. Okay, na? Next. Question number 95 is over. Next. 96. See what they are given. The waves of 600 nanometer, sorry, micrometer wavelength are instant normally on a slit of 1.2 millimeter width. Means small a given 1.2 millimeter. Lambda given 600 micrometer. Micro means 10 to the power of minus 6 nana. Okay. Value of diffraction angle corresponding to first minima. Yes, I'll solve this. Diffraction angle corresponding to first minima. Okay. See, diffraction angle corresponding to first minima. Nana. See, for first minima or first maxima, we know the formula. Sin theta 1 is equal to, so when we are doing that experiments, we have got first sin theta 1, sin theta 2, sin theta 3 derivation once you see. Okay, what they are asking for first minima, sin theta 1 should be equal to first minima, no, lambda by a, this should be there. Okay, yeah, so sin theta 1 is equal to lambda value how much you want to 600 micrometers 10 to the power of minus 6 upon 1.2 millimeters 10 to the power of minus 3. Yeah, so sin theta 1 becomes 6 into 10 to the power of minus 4 it is correct. Two zeros cancel with the minus 4. Okay, 1.2 can be written as 12 into 10 to the power of minus 1. So due to that it will become 10 to the power of minus 4. Can we write? Yes, we can write. So 1.2 10 to the power of minus 3 can be written as 12 into 10 to the power of minus 4. Yes, we can write. I am removing the point there. Minus 4, 10 power minus 4 cancel. 6 1 is a 6 2 jar. So sin theta 1 you are getting 1 by 2. So in sin theta 1 by 2 where you will get for an angle of 30 degrees. 30 degrees in radians can be represented by pi by 6. Yes, option 2 is there. Pi by 6. Got it, students? Remember this, Nana. JE students, remember this, and NEET students also, however. Mainly JE students remember. Okay. Next. Question number 97 now. In front of our diffraction, center of diffraction image is always brighter. Yes. Center of diffraction is central bright fringes is always brighter. Okay, always dark is wrong. Sometimes bright, sometimes dark is wrong. Bright for large wavelength, dark for low wavelength. No, it doesn't depend upon the wavelength. Okay, always bright. Next, question number 98. A single slit of width small d is placed in the path of a beam of wavelength lambda. The angular width of principal maxima obtained is, so fringe width of principal maxima how much Nana? Is 2 lambda capital D by small a. Small a is a slit width, but they have given that slit width is cap small d they have given. Okay, I am using small d only. Okay, now what they are saying, angular width is what Nana? Angular fringe width is nothing but beta by capital D. Do you remember this? In Young's double slit experiment I have explained you this one. Means 2 lambda capital D by small d upon capital D. Capital D cancel. You will get 2 lambda by small d. Yes, 2 lambda by small d. Option 3 is right answer. Got it, students? You need to remember this. Angular width means nothing but for fringe width divide with the distance between the screen and slits. You will get the angular fringe width theta. 98. This is also important, Nana. JE students, important. Next. 98 is over. Next. 99. What they are given? See there. They are given that easy question. The bending of light at the sharp edges of an optical is known as diffraction. Easy question. Diffraction and interference of light refers to wave nature of light. Important. Diffraction and interference of light refers what they will explains wave nature of light. Next, phenomena of diffraction of light waves are discovered by important Students, they will think that Fresnel. Fresnel is wrong. It is discovered by Grimaldi, scientist. Whereas later on, Fresnel has proved that. Fresnel has proved, but discovered by Grimaldi. Remember the name of the scientist, Grimaldi. Name of the scientist is Grimaldi. Okay. Next, 101 over. Next 102. The angular width theta of central maxima of diffraction pattern of a single slit depends upon. Just now I have written angular width of central maxima is how much you got? 2 lambda by small d or small a. You got correct? Yes. So it depends upon distance between the slits and screen. No. So they are saying that does not depends upon distance between slits and screen. Yes, correct. Wavelength of light, it depends. So it is wrong answer. Width of the slit, it depends. So wrong answer. Frequency of light, it depends. Wavelength is there means frequency also depends. Okay. Yeah. So it does not depends upon distance between the slits and screen. Because there is no capital D, capital D here. There is no capital D here. Capital D is not there. So does not depends upon the distance between the slits and source. Okay. Next. Red light is generally used to observe diffraction pattern from single slit. If green light is used instead of red light, then diffraction pattern is distance of diffraction pattern for maxima or minima n lambda capital D by small a. Means if wavelength of light is more, diffraction pattern will be more. Or fringe width, if we discuss, it is lambda capital D by a. Means fringe width also depends upon wavelength, directly proportional. Means wavelength is more means diffraction also more. Wavelength is less means diffraction also less. Got it? Now what they are saying, red light replaced with green light. We know that wavelength of red color light is greater than wavelength of green color light. Clear? That means wavelength is decreasing. When wavelength decreases, fringe width also decreases. Fringe width decreases means diffraction is decreasing. Okay, that means fringes will become more contract. Clear? So they will become more contract. Need students, you need to remember this type of questions. Conceptual based questions. Okay, na? Clear? Next. Question number 104. Diffraction of sound wave is more evident than light because wavelength of sound is more than wavelength of light. This is the reason. Sound produce more diffraction effect. Due to that reason only we can hear, even though when you are inside a room, but you can't see a person. Reason is diffraction will be more for sound because their wavelength is more. That is the reason. Okay. So wavelength of sound is more than wavelength of light. 104 is option 1. Nana. Clear? Next. 105. They have given 105. In single slit Fraunhofer diffraction, which of the wavefront is used? Fraunhofer diffraction it is. See, Fraunhofer diffraction means a plane wavefront. Important question. Whereas in Fresnel diffraction, it may be what? Cylindrical or spherical. Remember, Fresnel means cylindrical or spherical, whereas in Fraunhofer means it should be plane. However, it cannot be elliptical. Okay, next 106. In Fraunhofer diffraction, due to single slit, the slit width increases. Slit width A increases. Then width of central maxima. Width of central maxima is 2 lambda capital D by small a. If A increases, beta decreases. So decreases. Diffraction cannot be shown. Clear? Yeah. So this is all about your interference, diffraction. These are things. Now next last topic. Polarization, Brewster's law and Malus law. About this already few points we have discussed. So many questions we have discussed. Objective points we have discussed already. Just read them, go on ticking. Easy questions all are this. Okay. Every point we have discussed on this. Clear? Students, are you understanding what I am saying? Okay. No, time is also over. Next, after this, you are having previous year questions. Here, see, previous year questions are there. You try to solve these all by concepts, whatever I have given till now. You try to solve them, you will get the answers. If you will not get the answer, just send to my WhatsApp number. I will explain you. Okay? Whenever you are having doubt, just send to my WhatsApp number. I will explain you. Okay? And one more thing, and one more material also I will send. Narayana material also I will send. You solve that material also. This wave optics. Okay. Next, tomorrow I am going to take objectives of after wave optics. What chapter you are having? Dual nature of matter and radiation. No, that chapter objectives I am taking. First we will complete this serial. Okay. Then we will come back to first chapter, first book. Next chapter I will take, what is that one, Anna? Dual nature of matter and radiation chapter. I'll take objectives. And however, tomorrow you are having exam on wave optics chapter, subjective and objective exam. Okay. And one more thing, students, you have to